So we have a definite integral of an absolute value function. In other videos on this, I've talked about the technique of graphing this function. When you get the graph, you have basically a V-shaped function with two linear functions, figuring out what are the equations of each of these two lines. And that's a great way to visualize what's happening, but frankly, all those extra steps take time that not really necessary. All that's really necessary is remembering the concept of absolute value. So an absolute value, I have two different possibilities. I can put absolute value where I put in a positive, or I have an absolute value where I put in a negative. When I'm putting in a positive, I put like a positive 5 into an absolute value. What comes out is the same thing as what goes in. If I put in a negative, like negative 3, well, what comes out is the opposite of what I put in, be positive 3. So that's pretty simple when you think about it. So when I want to evaluate a definite integral that involves an absolute value function, I spend a little time to figure out when does this expression equal 0, and then check on either side of that 0 boundary to find out when this absolute value expression gives me a positive value. So for those x values, I just evaluate the integral at this expression. And for any x value that gives me a negative here, I would evaluate a definite integral using the opposite of this expression. So that's not that cumbersome. It's not that hard. It takes a little bit of time, but it's not too bad. So the real question is, when does 2x minus 6 equal 0? Well, it's like when what? When 2x equals 6 or x equals 3. Okay? So I want to examine values of x greater or lesser than 3. So I do a simple little number line here. All right, and so at 3, and if I look at values of x less than 3, let's say at 2, that would be 2 times 2 minus 6. That'd be 4. That's going to be a negative number. So any value of x less than 3 gives me a negative value inside this absolute value expression. And for any value greater than 3, let's say if I pick 4, so that's 2 times 4, that's 8 minus 6. Well, that's going to be positive. So for any value of 3 greater than, any value of x greater than 3, I get a positive value here. So if I want to evaluate this definite integral, I can evaluate two separate integrals. First of all, for any value of x greater than 3, I'll just evaluate 2x minus 6. Forget the absolute value. And for any value of x less than 3, I'll evaluate the opposite of this. And the opposite of that would be negative 2x minus 6, or 6 minus 2x. And on anything greater than 3, I'll just evaluate 2x minus 6. So I'm going to basically evaluate the sum of two definite integrals. So this expression that we're given is going to equal the integral. One of the integrals is going to be from 0 to 3. In other words, I'm going to start, I want to cover this entire interval from 0 to 4. But from 0 to 3, I'm going to evaluate the opposite of this. So it'll be a definite integral of 6 minus 2x dx. And then for values greater than 3, in this case, it'll be from 3 to 4, I'll evaluate, well, the function that's actually inside the absolute value brackets, 2x minus 6 dx. Okay, simple as that. Now, take the antiderivatives. Antiderivative of 6 is simply 6x. Antiderivative of 2x is 2x squared divided by 2. Okay, and I'm evaluating that from 0 to 3. Plus the definite integral, okay, this one, 2x minus 6, so the antiderivative of 2x is again 2x squared over 2 minus 6x, and this will be from 3 to 4. And it should not be a surprise that these two antiderivatives look very similar. They're just the same thing but in reverse order, right? So now just do the arithmetic. So this equals, and I dropped the 3 in here, so 6 times 3 is 18. 3 squared is 9. The 2 top and bottom cancel, so it's 18 minus 9. And when I evaluate it at the 0, well, the 0 goes into either of these terms. I just get a 0, so this is minus 0. Okay. Now the second half of this, or second part of this definite integral is 2x minus 6. And so the antiderivative here, evaluated at 4, goes in here, and it gives me 16. Okay. Minus 6 times 4 is 24. Now I'm going to evaluate the same thing at 9, and I get 9 minus 6 times 3 is 18. Let's just check all the signs. 6 threes are 18, that's positive. 3 threes are 9, that's subtraction there, minus 0. So 4 goes in over here, that's 16, that's positive. Minus 24, that's a negative. And I subtract from that, I drop in 3, that's 9, minus 18. Okay, so a bunch of arithmetic. So I'm just going to gather all these numbers and then do the addition and subtract. So it's 18 minus 9. I'll ignore the 0. Then over here on this side, I get a plus 16, a minus 24. Here I get I just distribute the negative sign, so minus 9, and then minus 18 is plus 18. Okay. So it's a lot of numbers. But I noticed one thing I could probably do right here to make this a little bit easier. I've got an 18, I got a pair of negative 9s. That sort of cancels out. So I can just basically cancel out this, and this. And I end up then with 16 plus 18 minus 24. Is that right? So 16 and 18 is 34 minus 24. That equals 10. And we're done. And so again, take the time, figure out where this expression equals 0. Test this expression on either side of that to figure out when you have to use the opposite expression, and then set up your multiple definite intervals.